Welcome to the 18th video in the Metric Math Water Wastewater YouTube series. This video is going to focus on solving simple dilution problems using the formula C1V1 equals C2V2. Today's question reads as follows. How many liters of water and how many liters of a 24% stock solution of chemical is needed to dilute down to form 135 liters of a 7% solution? When we take a look at this question, there's a number of key things that you need to focus on right off the bat. First of all, what is the percentage of the stock solution? Now, a stock solution is your concentrate, and you're going to add water to the concentrate to bring the percentage down to a more safe, economical, easy to handle concentration. Now, in this case, the stock solution is 24%, so that's your concentrate. The new solution, the diluted solution, what is its concentration? What does it need to be? Well, it's going to be 7%. What is the total volume of your needed diluted solution? That's stated to be 135 liters. Now, what are you trying to find in this particular question? It's asking how many liters of water added to how many liters of the concentrate or the stock solution. How many liters of each are you going to need to make 135 liters of a 7% usable solution? Now, when we talk about dilution, what does that actually mean? So if you start off with a cylinder or a container, it doesn't matter, a measurable container. In this particular container, you add a given amount of stock solution, and that's what we're trying to find. How many liters of this are you going to need? Now, we don't know how much water you're going to add to it, but you're going to have to add some because you're diluting the 24% solution. At the end, when you are done, you're going to need 135 liters of 7% solution. So you're given three variables here. You're given 24% solution, you're given 7% solution, and you're given a volume of the 7% solution. Again, the question is how many liters of water? How many liters of this concentrate stock solution are you going to need to make 135 liters at 7%? Now we have to establish what formula are you going to use. And the formula that I would highly recommend is this C1V1 equals C2V2. Well, what does it stand for? Concentration of your first solution multiplied by the volume equals the concentration of the second multiplied by its volume. And the whole idea here is as the concentration of one of these variables goes up, you don't need as much of it. The volume will go down to equal out a different concentration and a different volume. And that makes sense. You need just a tiny amount of concentrate, as in volume, of highly concentrated to equal out a large volume of a dilute. That's the whole idea behind this formula. Now using the numbers from the given, notice the 24%, we don't know how many liters of that it's going to be. So that's your unknown volume. We know that we have 7% and we know that it's 135 liters. So again, 3 out of the 4 variables we do need. Now you can solve the formula. Again, 24% times the volume equals 7% of the 135. Now, just a quick little note. Notice the concentration on the left side is quite high. 24% is higher than 7%. Therefore, if they're going to be equal, the volume is going to be a lot less than 135. So that's a little mental note or a checklist or a flag. You can predict that the volume has to be less than 135 liters. When we put the numbers in there, you notice you've got 24 is on the left-hand side. You have to bring it to the right side. You have to bring all your known values on the right-hand side. And how do you do that? You divide both sides by 24. Notice they cancel out. Any number divided by itself is 1. And you're left with the volume is equal to 7 times 135 divided by 24. And notice how the units on the percentage cancel out. And what will you be left? You're going to be left with a unit of liters. And notice that liters is the acceptable unit for volume. Answer is about 39.375 liters of the 24% stock solution. So now we can put that into our little picture to help us understand this a little bit better. We know now that you need 135 liters of the 7% solution. That just came from the original information. We know that you don't need as many liters of the 24% because it's more concentrated. The volume of that is going to be 39.375. So that means that when you take the volume of the 7%, 135 liters, that's going to be equal to the volume of the concentrate plus the amount of water that you add into it to dilute it down from 24 to 20 to 15 to 10 to 7%. That value is going to work out to 135 liters minus 39.375, and that works out to approximately, for the concentrate, it's going to be 39.375, and the volume of the water is going to be that subtraction. 135 minus 39.375 works out to approximately 95.625 liters of water. Now, adaptation of this formula. This is probably one of the most easily adaptable formulas of any one that I'm aware of. Why? Because there is no specific unit for concentration. It could be percent, it could be grams per liter, it could be milligrams per liter, it could be kilograms per megaliter, it could be grains, it could be any unit, grams per 100 mils, like it doesn't matter. So that unit, as long as the unit is the same on the left side and on the right side, you can use whatever you want. Likewise, as long as the unit is the same on the left side for volume as on the right side, you can use metric, you can use volume, could be liters, could be cubic meters, could be megaliters, could be imperial gallons, could be an American gallon, could be a Canadian gallon, could be cubic feet, like who knows. As long as your units are the same on both sides of the equal sign, they'll cancel out and you're going to have what you need to do. Thanks for watching this math video. Please check out the other videos in this channel, put in some comments, and pass the site on to any other math students who are working on their water and the wastewater questions. Bye for now, and have a good day.